Hello, this is Math 18, Section 3.2. Today we're going to be looking at how to find the least common multiple of two or more numbers. So first of all, you need to know a couple definitions. The multiples of a number are the numbers that you get, the products that you get when you multiply the number that they've given you by 1, 2, 3, 4, and 5. So let's say, for instance, that I ask you to give me the multiples of 3. Okay, so if we start with 3, you start and you multiply 3 times 1. Well, that's 3. 3 times 2, 6. 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, and it goes on for forever, okay, from there on out. So somebody said, you know, how many multiples are there of 3? There's an infinite number because it just keeps going. Now, so we're not going to find all the multiples of a number. What we're looking for is what's called a common multiple. So if you have two numbers, sorry about that. A common multiple is going to be a multiple that's in both sets of multiples for those numbers. So look, for instance, down here. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, and so on. Okay? Then I've listed some of the multiples of 6. 6, 12, 18, 24, 30, 36, 42. Well, if you notice, the ones that are in bold print, those are common multiples because they're in both lists. 12 is a multiple of both 4 and 6. 24 is also, and so is 36. And there's probably a whole bunch more that are common multiples to both 4 and 6. Now, what we'll be looking for today is what's called the least common multiple. So what that is when you find some multiples of two or more numbers, the least common multiple is the smallest multiple in that list, that's common to all those lists of multiples. So if you look back at 4 and 6, the smallest common multiple is 12. So also think about, like, if you had fractions and you had 4 and 6 as the denominators here, and I said, okay, what's the common denominator? Because this is something that we're going to look at later on in this chapter. You would have to think about, what do 4 and 6 both go into, and they both will divide evenly into 12. So the least common multiple and the least common denominator are the exact same number. It's the same thing. So that's what we're going to be looking at, how to find that least common multiple today. All right, so this is what we just said. The least common multiple of 4 and 6 is 12. So one way that you can find the least common multiple is to start and list the multiples of each number until you find one that is in both sets of lists, in both lists, okay? And once you find that least common multiple, that's the answer, okay? That's the whole idea. However, most people say, well, that seems pretty easy. You just got to keep multiplying. Some of these common multiples can be huge numbers, and you will be sitting there listing multiples all day long before you find the stupid answer. So another way that you can find the least common multiple uses prime factorization, which we just looked at back in section 3.1. So that's the way we're going to look at doing these problems because it's so much easier. All right, so here's what you do. When you are finding the least common multiple, your first step is you're going to write the prime factorization of each number. So remember, prime factorization, those are the factor trees that we just did in the last section. Okay, you prime factor each number. Now, after you've done that, you want to write the factorization out in a line. So in other words, if the factorization is 2 times 3 times 3, you write that 2 times 3 times 3 in a line. And you want to keep, like, if there's more than one 3 or, 3 2s or whatever, you want to keep all the 2s together and you want to keep all the 3s together so that you can see the biggest number of those factors in your line. Okay? Then you go back, and you'll have at least 2 lines because you have to have 2 numbers or more that you'll be finding the least common multiple of. So you go back, and in each individual line, you look at each line and say, okay, there's 2s in, say, the top line and the bottom line. Which line has the biggest number of 2s? Whichever line that is, you go and you circle all of the 2s in that line. Say you've got 3's in both lines, you find which line has the biggest number of 3's and you circle all those 3's. And then once you've circled those factors, the least common multiple is what you get when you multiply all those circled numbers together. So I know right now when I'm just talking about it and you can't really see it until we do a problem, it doesn't make much sense, but it will in a minute. Okay? So let's look at a problem. All right, number 1, find the least common multiple of 14 and 12. Now, a common mistake is people look at 14 and 12 and they say 2. 2 is a common factor, not a least common multiple. So a multiple is always going to be, like with 14 and 12, the smallest answer could be 14 or bigger. Okay, it's not going to be smaller than 14 or 12. It has to be a larger number. Even though the L in least in LCM stands for least, think about it as large. Your answer is going to be a larger number than the numbers that you've been given. Okay, so remember our first step from the previous slide. We're going to take 14 and we're going to prime factor it. Okay, and we're going to do the same thing with 12. Okay, so 14 I want to break down into 2 times 7. Now remember, because we just did prime factorization, so 2, 3, 5, 7, maybe 11, but 2, 3, 5, and 7, those are the main ones you're going to be dealing with for prime factors. So 2 is prime, so is 7. So I circle both of those. So 14 is done for now. Now let's do the same thing with 12. So you can use 3 and 4, you can use 2 and 6, it doesn't matter. I'm going to use 3 and 4. 3 is prime. Okay, 4 I can break down into 2 times 2. And those are both prime. Okay, so 12 has been prime factored. Now, to me, this is, if I just look at those trees the way they are, I can't tell what the LCM is. So what I think helps a lot is to write the prime factorization out in a line. So 14 is 2 times 7. Okay, that was the next step in the directions. Write it in a line. All right, number 12 is going to be, and I'm just going to keep it in numerical order so that it's kind of starting with the smallest up to the largest. I've got 2 times 2 times 3. Okay, so here's the thing. You have to include every different factor and you have to include it the largest set of those factors. Okay, so here's what you're going to do to circle. First of all, look at your factors here. We've got 2's, we've got some 3's, and we've got some 7's. Okay, you have 3 different factors: 2's, 3's, and 7's. Okay, hopefully everybody sees that. So what that means is you're going to have 3 circles. You have to have a circle for the 2's, a circle for the 3's, a circle for the 7's. Okay, so however many different factors there are, say there's 5 different factors, you're going to circle 5 things. You're going to have 5 circles. Okay, so let's start with the 2's. Look at the top line with the 14. You have 2 times 7. There's only one 2. Look at the bottom line. There's 2 2's. We're trying to pick out the largest set of 2's. So I'm going to circle the 2 2's in the bottom line. Okay? Now, the next number up is 3's. Well, there's only one 3, but it's a different factor from the 2's, so I have to include that 3. Okay? And the only other factor is the 7, and it's different from the 2's and the 3's, so I circle the 7. Now notice I did not circle the 2 in the top line of the 14 because there was a larger set of 2's in the bottom line with the 12. So now the hardest part is figuring out what to circle. That's the hardest part, and we're going to work on that a lot. We've got a lot of examples to help you get this. All right, is you're going to go back, and the least common multiple is going to be the product of what you circled. Okay, so we circled 2 times 2 times 3 times 7. Okay, so I'm going to show you it all multiplied out, and then I'm going to show you a little bit of a shortcut in just a sec. So you just multiply these. Well, 2 times 2 is 4. So 4 times 3 times 7. So then we have 4 times 3 is 12. And 12 times 7 gives me 84. So that means that the least common multiple of 14 and 12 is 84. That is the smallest number that both 14 and 12 will divide into evenly. Okay? Now, so if you were doing it the way of listing out the multiples, you would have to go all the way out to whatever 14 excuse me, 14 times whatever gives you 84. And that's, some of these answers are going to be really big, and you'd be writing multiples all day long. This didn't take us long at all. The other part that makes this easier, when you use the prime factorization, you're using much smaller numbers. I mean, after about 14 times 2, I have to get on a calculator to figure out what the next multiple is. And even if you have a calculator, I can do the prime factorization a lot quicker than I could multiplying all those on a calculator. So in the long run, this is a much quicker way of finding your least common multiple. Now, one of the shortcuts I was talking about, look at what we circled on this bottom line of 12. We circled all those numbers there, 2 times 2 times 3. Well, if I've circled that entire line, okay, that entire line is equal to the 12 there. So a shortcut would be when I go back to multiply, since I circled that entire line of factors, I know that's 12 times the last circle, which is 7, and then if you can't remember your multiplication tables, that's the first time you're touching a calculator, is 12 times 7, and there's your common multiple. So really, if you use the prime factorization, it's going to make it a lot easier in the long run. Let's look at some more. Number 2, find the least common multiple of 50 and 24. So you're trying to think of a number that both 50 and 24 will divide into. It's going to be a big number. We don't know, okay? So the first step, prime factor, 50 and 24. Okay, so I'm going to use 5 and 10 for 50 because that's pretty simple. 5 is prime, so I circle it. 10 will break down into 2 times 5. And those are both prime, so I circle them. And now 50 is done, okay? So let's come over here to 24. I'm going to use 4 times 6. And then 4 is not prime. I can break that into 2 and 2. Those are prime, okay? Now, let me ask you this. What if you had used 3 and 8 for 24? Would that be okay? Heck yeah, because it's still going to come out to be the same factorization at the end, as long as you're careful and that you have the right factors there. Now, 6 can break down into 2 times 3, and they're both prime, so that's done. So for 50, I've got 2 times 5 times 5. So whenever you have multiple factors that are the same, make sure you keep those together so that you see in that top line I've got 2 5s. You wouldn't want to have them split up and not realize that you have 2 5s there. So you want to keep them together. Like on the 24, I definitely want to keep all of the 2's together and then that 3. Okay? So look at what we have here. We have 2's, 3's, and 5's. That's 3 different factors. That means I'm going to have 3 circles. So look at the 2's. I have 1 2 in the top line, but I have 3 2's in the bottom line. So that means the biggest number of 2's is in that bottom line. I'm going to circle that. Okay? Circle all of the 2's in that bottom line. And you'll only have 1 circle of 2's. So that's what tells you, okay, I'm never going to circle that other 2 at the top because I've already got a circle of 2's. Now, the next different factor is either the 3's or the 5's. I'm going to circle the 3. There's only that one 3, so I have to include that. It's a different factor, okay? And then the other different factor is the 5's. So I circle both 5's, okay? Now, that's a lot of numbers. But look what's happened here again. We've circled that entire bottom line. That entire bottom line is equal to 24. So instead of doing all that multiplication over again, take that shortcut. 2 times 2 times 2 times 3 is 24. Okay? So I have 24 times 5 times 5. Well, 5 times 5 is 25, right? Now, this is the first time that I'm having to touch my calculator. 24 times 25 is, the least common multiple, is 600. So you would have to go all the way out in a list of multiples, all the way out to 600. Ain't nobody got time for that. Okay, you don't want to do that. All right, so you'd be writing them all day long, and by the time you got the answer, you'd be like, who cares? So this is so much faster, and most of them you won't be touching your calculator until that last step when you have to do, 2 large numbers to multiply. That's it. Okay. All right, let's look at the next one. Number 3, find the least common multiple of 45, 54, and 50. So now we have three numbers that all have to go into the same number. Okay, so let's start with our prime factorization. We have 45. I'm going to use 5 times 9. 5 is prime, and 9 would be 3 times 3. And those are both prime. Okay, so now we move on to 54. Well, 54 is 6 times 9. So a lot of times you can just use plain old multiplication tables and it makes it a lot easier. 6 I can break down into 2 times 3. Those are both prime, so you circle those. And then 9 would be 3 times 3, and those are both prime. So make sure that you've got it all broken down to where the last, the end of your branch ends in a prime number. That's very important. All right, and 50, we just did that a minute ago, but let's write it out again. We've got 5 and 10. 5 is prime. 10 would be 2 times 5, and those are both prime. Okay? So 45, I'm going to write it as 3 times 3 times 5. Okay? 54, I have 2 times 3 times 3 times 3. Okay? And 50, just keeping them in numerical order, 2 times 5 times 5. All right, now this is the circling part, so this is where you got to be careful. You've got 2's, 3's, and 5's. So we have three different factors. That means we need 3 circles, okay? Now, this is something that hasn't, it's going to come up right now. All right, so let's start with the smallest number. This is good. The smallest number is a 2. Well, there's a 2, just one 2 in the 54 line, and there's just one 2 in the 50 line. So which one has the bigger number of 2's? Well, they're the same. So here's the deal. It doesn't matter which one you circle, but you only circle one of them. Okay, because there can only be one circle for the 2's. So I'm going to circle the bottom 2. I could have circled the 2 in the middle and it would not have made any difference at all. Okay, so but I'm just circling the one on the bottom. All right, doesn't matter. Now, we're done with the 2's for now. Look at the 3's. I have 2 3's in the top line and I have 3 3's in the middle line. Well, the biggest number of 3's is in the middle, so I'm going to circle those 3's right there, all 3 of them. Okay, so that's my 3 circle. Now look at the 5's. I've got a 5, 1 5 on the top line, 2 5's on the bottom line. So that you want the biggest number of 5's. You're going to circle both of those on the bottom. Okay, now, we've got a nice shortcut here. Look at this. Least common multiple. We've circled the entire bottom line. The entire bottom line is equal to 50. Okay, and then we're going to multiply it by 3 times 3 times 3. So what I would do is bring down the 50 and multiply 3 times 3 is 9 times 3 is 27. Now I pick up the handy dandy calculator, and 50 times 27 is 1,350. So the least common multiple is that big huge number, 1350. Can you imagine writing out all the multiples of three separate numbers until you hit 1,350? No, yuck. You don't want to do it. This way is so much easier. Okay? All right. So, and we do have lots of examples in this section. So if you start to, lose your attention or you're fading out there, stop it and take a break and then come back to it. Okay? All right, so find the LCM of 15 and 12. So once again, start with prime factorization of 15 and 12. 15 is 3 times 5. Those are both prime. 12, I'm going to use 3 and 4. 3 is prime. 4 would be 2 and 2. And those are prime. Okay, so 15, I have 3 times 5. 12, I've got 2 times 2 times 3. Okay, so I have 2's, 3's, and 5's. So the biggest number of 2's is down here in the second line with the 2 2's. I'm going to circle those. Okay? All right, the 3's will have the same number of 3's in both lines, so it doesn't matter which one I decide to use. So I'm going to circle the 3 on the bottom because that gives me a shortcut there because now I've circled that entire bottom line. All right, and then the only other factor that's different is the 5, so I have to circle the 5. So to get our answer, we've circled the entire bottom line. That's equal to 12 times the 5. 12 times 5 gives you 60. And that would be it there. Okay? All right. Number 5. Find the LCM of 10, 15, and 8. So if it was just 10 and 15, that wouldn't be too bad. But when they throw that 8 in there, it makes it kind of weird. Okay? So let's start with the prime factorization. 10 would be 2 and 5, and that's done. It's nice and quick. 15 is just 3 and 5, and those are both prime, so that's done. 8, we can use 2. Oops, I wrote the 4 first. Sorry, 4 times 2. 2 is prime, but 4, you have to break that down into 2 and 2 so that you have all those prime numbers. Okay? So definitely after this section, you will be like the prime factor master. Okay? You'll be growing all these trees. You'll be like a forest ranger. All right, so 10, let's write that out. We've got 2 times 5. 15 is 3 times 5. And 8 is 2, 2, and 2. All right. So we've got 2s, 3s, and 5s. We have a lot of those on all these problems. The biggest number of 2s is down here in the bottom. So you circle all 3 of those. Okay? The biggest number of 3s, there's only 1. Circle that 3. And the biggest number of 5s, either one. They're both just 1 5. So I'm going to circle the middle one there so that now I've got that whole line is circled, which means that middle line there for the 3 times 5, I can just write 15. And I also circled the entire bottom line, which was 8. And so now, I don't know my 15 times tables, so that's really bad. 15 times 8 gives you 120. And that's your answer. Okay? All right, number 6. Find the LCM of 68 and 76. All right, 68. I don't know any multiplication tables for that. So it's even. I'm just going to divide it by 2. And that gives me 34. Okay, 2 is prime. 34 is even. So I can still divide by 2. And that gives me 17. 2 is prime. So is 17. So 68 is done. Okay. Now let's do 76. So once again, that's a pretty big number. I'm going to divide by 2. And let's see. 2 times 3 is 6. 38. Let me double check that. That is right. Okay. 2 is prime. 38 is even, so I'm still going to divide by 2. And that gives me 19. So 2 is prime. So is the 19. Okay. So 68, write your prime factorization out in a line. 2 times 2 times 17. And 76 is 2 times 2 times 19. Okay? So we have 2's, 17's, and 19's. 3 factors. That means 3 circles. So the biggest number of 2's, well, you've got 2 2's on top, 2 2's on the bottom. Doesn't really matter. So I'm just going to go ahead and circle the 2's on the top. And you also have to circle the 17. That's a different factor. And the 19. Okay? So we circled the entire top line, which was equal to 68. And then the other factor was 19. So now 68 times 19, wow, big number, is 1,292. And that is your least common multiple there. Big number. All right. So now, here's some you tries. So pause the video, try these on your own. I think that there's 4 or 5 of these. There might be 5, okay? And you can go back and check yourself. All right, number 1, find the LCM of 6 and 10. So those numbers aren't too big. It's not too bad. We're going to start with the prime factorization. Okay, 6 is just 2 and 3, both prime. 10 is 2 and 5. Those are both prime. All right, so let's write them in a line. 6 is 2 times 3. 10 is 2 times 5. All right, so we have 2's, 3's, and 5's. So I need 3 circles. I'm going to circle a 2. Doesn't really matter which one, okay, because they're the same number of 2's. You have to circle the 3. That's a different factor. And you also have to circle the 5. So we circled the top line, which was 6, times 5 gives you 30. Now, a lot of people will say, well, I can figure that out without having to go through all of this. And if you can, that's fine. But on that last problem we just did, what was it, 1,292? I don't think you're just going to pull that out of your hat. It's not going to happen. So you have to know steps to get it if they're really crazy numbers. All right, number 2. Find the LCM of 4, 8, and 20. Okay, so start with your prime factorization. 4 is 2 and 2, both prime. All right, 8 is 2 and 4. 2 is prime. 4 breaks down one more time into 2 and 2. Okay? 20, I'm going to use 4 and 5. So 5 is prime, but I need to break the 4 down one more time into 2 and 2. Okay? So let's line them up. 4 is 2 times 2. 8 is 2 times 2 times 2. And 20 is 2 times 2 times 5. All right, so on this one, we only have 2 different factors, 2's and 5's. So we're only going to have 2 circles. The biggest number of 2's is here in the middle. There's 3 2's there, so I circle all of them. And the only other different factor is the 5, so I circle the 5. Okay, so we circled the entire middle line there. 2 times 2 times 2 is 8. We bring that down, times the 5, and you get 40. And that's your least common multiple. All right, number 3. Find the least common multiple of 3, 8, and 16. Okay, now this one's kind of weird. 3 is a prime number. So what we're going to do is we're not going to prime factor it because it's already a prime number. So when we write the list, I'll show you what we're going to do. You have to include the 3 there. That's very important. So we don't have to prime factor the 3. We're going to leave that alone for now. 8 we just did a minute ago. 2 and 4. 2 is prime. 4 breaks into 2 and 2. So that's done. Now 16, I'm just going to use 4 times 4. And then you've got 2 and 2 for the first 4, and 2 and 2 for the second 4. So those are all prime. Okay, so here's what you have to do for the 3. When you write 3, you just have to write equals 3. So you have to include that 3 there. It's really weird. Okay, if it makes you feel better to put 3 times 1, that's fine, but 1 is not a prime number. So I would just write 3. If it's a prime number, say if it was 5, you would just write 5. Okay, now 8 is 2, 2, 2, and 16, we have 1, 2, 3, 4 2's. Okay, so this is why you have to have that 3 there, because you have 2 different factors, 2's and 3's. So the biggest number of 2's is down here on the bottom. Those 4 2's, circle all of them. And then the other different factor is the 3. So your least common multiple, we circled the entire bottom line, so that's 16, okay, and that's our shortcut there, times the 3, so our least common multiple is 48. All right, let's look at the next one. Find the least common multiple of 9 and 24. Okay, so once again, start out with 9. Prime factor would be 3 times 3, okay, and those are both prime. 24, I'm going to use 4 and 6. 4 would be 2 and 2, and those are prime. And 6 would be 2 and 3, and those are prime. Okay, so let's line them up. 9 is 3 times 3. 24 is 2, 2, 2, and 3. Okay, so we have 2 different factors, 2's and 3's. The biggest number of 2's is down here in the bottom line. So you circle all 3 2's. Now look at the 3's. The biggest number of 3's is in the top line. You've got 2 3's there. Okay? So we circled that first line completely, which was equal to 9 times 2 times 2 times 2. Well, if you multiply those 2's there, 2 times 2 is 4, times 2 would be 8. And then 9 times 8 gives you 72. So that's the LCM of 9 and 24. All right. Ooh, here's a big one. Find the LCM of 36, 42, and 30. Okay. Ooh, some big numbers. 36. I'm going to use 6 and 6. And then 6 would be 2 times 3. And the other 6 would be 2 times 3. And those are all prime. So 36 is done. All right. 42. I'm going to use 6 times 7. 7 is prime. 6 I can break down into 2 times 3. And now 42 is done. And the last one, 30, I'm going to break down into 5 times 6. Or if you use 3 times 10, that's perfect. 2 times 15, any of those work. 5 is prime. 6 would be 2 times 3. Okay, so now we want to go back and write them in a line. Now, make sure with the 36, it's kind of all scrambled up. I've got 2 2's, I want to keep them together, and I've got 2 3's. Keep those together so that you see 2 2's, 2 3's, okay? On 42, they're all different. 2, 3, 7, okay? And on 30, I have 2, 3, and 5. Okay, so we've got 2's, 3's, 5's, and 7's. That's 4 different factors, which means I need 4 circles, okay? So look at the 2's. The biggest number of 2's is in the top line. Circle both of those, okay? Now look at the 3's. I've got 2 3's on the top and 1 3 each in the middle and the bottom. The biggest number of 3's is also in that top line, okay? And then the other different factors, I need to circle the 5 and the 7. Okay, so look at what you have. We circled the entire top line, so that's going to be 36. Okay, now look at the other two factors. 7 times 5 is 35. That's where I got that. Okay, so if you are wondering, like, where the heck did she get the 35? I multiplied the 7 times 5. And now, once again, the first time ever, for the problem anyway, use your calculator. 36 times 35 is 1,260. And that is your least common multiple. So, that should be it for section 3.2. Yep, sure is. That's it.